Alright, today we're doing Chapter 1, Section 3, Box and Whisker Plots. And I don't know if I'd bother writing this if I were you, but a box and whisker plot, essentially what it looks like is something like this, some rendition of this. And so they probably look familiar, but that's kind of where we're headed in today's notes. I'm actually going to flip to the example on the next page. So I want something that has an even number of data points. And in class, I'll ask people what age they'd most like to be. So I'm just going to make up some numbers because even my family's asleep. I'm the only one around right now. But I'm going to say somebody wants to stay 12 or be 12. Maybe we have a couple people want to go back to their childhood, so we'll put a 4 and an 8. A couple people want to be able to drive, so we'll throw in a couple of 16s and 18. Maybe people want to be out of college. So 35, maybe I don't know, 21, 50, and a 65. Well, 50 and 65 typically aren't student answers. So if we have those, first thing we need to do is we need to take and put these numbers in order because we want to find the median or the middle number. So I'm going to do that a second right below there. 4 was our youngest, so I'm going to write a 4. And often I'll either cross things out or underline them just to make sure that I don't forget something. But 4 and an 8, then 12 is next. And I would encourage you to do something to make sure you have the same number of numbers, whether that be cross them out or count them up at least. But every so often you get somebody who gets the answer wrong on a quiz or a test just because they missed one of the numbers. And I've been guilty of that myself. So 65. So I have that there, and we should have 4, 8, 9, 10 numbers. So there's all the numbers in order. And the reason we want to do that is we want to find the median or the middle of that set of numbers. So if I count over, I have like 3 numbers here, 3 numbers there, another number. So our median is going to be right there, right in the middle. And if you think back to yesterday's section, section 2, if you have 2 numbers that tie for the middle, the median is going to be the average of those. So I'd have to do my 16 plus 18 to find the mean or the average, and then divide by 2 because there's 2 numbers. Most people with a 16 and 18 will probably look at it and be like, oh, it's going to be 17. So when we had that box thing that I quickly drew on the front side, the middle part of that box is going to be at 17. So each of my numbers on this number line here, 5, typically I'll give you something like that on a test because I am looking for it to be to scale. So 17 is going to be something right about there. I'm doing it up high enough that I can write a 17 below it on my number line. So that's going to be the middle part of the box. Now what we can do is look just at this bottom half of the data over here, and we want to find the median again. So now here we'd have 12 is going to be right in the middle there. So the bottom part of my box is going to be at the 12. So partway between 10 and 15, a little closer to the 10. So I'm going to put that in. You don't have to do different colors. I'm just kind of trying to show where the different things come from. So that's my 12. And then to get the upper part of that box, we look at the upper part of the data, and when we have that, spending too much time trying to figure out which color to do. Okay, so the upper part is here. I have 5 numbers, so that middle number there is going to be the 35. So I have 30 there and 40, so 35 is right in the middle. So it's not always symmetrical, and we're going to kind of explain that a little bit more soon. That's there, we'd have a 35. Now the last thing that we had was, so this is the box, in the box and whisker plot. The last part we have is the whiskers, and the whiskers go to our maximum value, which is the 65, and the minimum value, which is the 4. So I'm going to start at the 4, so a little less than the 5, so right about there is going to be my 4, and we put in the number below it, always put in the number. So then I'd have 60, so 65 is going to be right out there. And put a line at 65, line and going out to it, and cut it there. So now what exactly do these different parts mean? Well, our 17, if we jump back to that one, we have our 17 right there. The 17 was the very middle number. So once I have this 17, I can know that half, or 50% of my numbers are here. And so half of my numbers, 50%, are here. And half of my numbers are over here to the right of the 17. So we know that that's the 50%. When I took it again and cut that, so say this bottom 50%, I cut it in half again, I now know that 25% of my numbers are right there. So each of these four parts, 25% is here, and the other half of my lower 50, 25% is there. So I have 25%, 25%. I did the same thing on this side. I took my 50%, which is all these numbers, cut it in half. So I know that 25% of the numbers are here. So I'm going to go and label that in a minute, and I'll maybe put it in brown. So we have 25%. Now when you're drawing out these box and whisker plots, you don't actually go through and do this. But what it's telling us is you can now look at this picture of the data. It's going to be especially helpful if you have way more numbers. You can say, well, most people want to be what age? Well, the most popular age, this here is my smallest group of 25%, so the data is crammed closest together right there. This is my next smallest group of 25%, so the next largest group of numbers. So most people want to be between 12 and 17. The second most between 4 and 12. The third most would be between 17 and 35, and the most people don't want to be kind of where I am, smack dab in this category. And no one wants to be older than 65, which, I don't know, you still got retirement coming at that point. Whether Social Security's there, who knows about that one. So I'm going to quickly write in, then we'll flip back to the first page. That right here, if you have a section that's small, then the data is close together. Then if you have a section that's large, you have that 25% that's spread out, the large, in the same way as the 25% spread out, the data spread out. Data, or maybe you'll say data far apart. I like how that sounds a little more. Okay, I'm going to flip back to the first page because that's getting kind of cluttered. And we'll look at a different example. So if we were to do this one here, well, let's actually write out what it is. So box and whisker plot, it's a visual way of showing median values. So a visual way of showing, because we were finding the middle number each time we were finding the median. So a visual way of showing median values for a set of data. And I want to do another example quick here. I'm just going to quick throw some numbers down. We'll actually put them in order. But if we were to go through and find, let's say we have a 10, a 15, a 23, a 25, a 35, go for a 62, 74, 81, and an 85. So this time I wanted to have an odd set of numbers, and just quick count it up, I do. And if we're going through, a little bit of a different thing happens here. If we're looking for our median is going to be this 35. There's 4 numbers above it, 4 numbers below it. So we start out the exact same way. So I have 10, 20, 30, 40. So we put a line at 35. Leave yourself enough room to put a number underneath it. So we have 35. Now the question comes up, when I'm trying to find that second median, the median of the bottom half, the median of the top half. Well, how do I do it? Before on the last page, I drew a box around, well, because then the median was right between something. So I could draw a box and say, hey, look at this half and this half of the data. But I can't do that anymore. And yeah, I know that my box went over there, but I can't do that anymore because do I put the 35 in both groups? Or how does that work? So instead, if you have one number being the median, it's not a tie. Now when we're trying to find the median of the bottom half and the median of the top half, you totally ignore that number. That number doesn't go on either side because it's right in the middle. So our second median is going to be the average of these two. So 15 plus 23 divided by 2, so we have 38. So divided by 2, so 19 is our lower number. So put a box just past the 20, 19. And our upper number is going to be the average of these two, or the mean. So 74 plus 81 divided by 2, so 155 divided by 2. So that'd be 75 plus 2.5, so 77.5. So we have 60, 70, 80. So 77.5, so right between 75 and 81. And 77.5. Our data is really spread out there. We got a long box there. Now last we put in our maximum and our minimum. So we're down at 10 for our minimum, our smallest number, and 85 for our largest number. And hopefully we didn't take up too much space up above because I want to go through and label some different things here. Let me slide this up a little bit. And that 35, that median, they will call that a quartile. So this right here, maybe I'll write it up above. It's a quartile. And if you wanted to, I suppose you could do the arrow this way too. But I don't know if that's going to be helpful or not. I'll actually take mine off. It already looks confusing enough. So quartile. Now when we find that second median, this thing we did here between 15 and 23, that's going to be called the lower quartile. So this number right here, the bottom edge of the box, is the lower quartile. And then knowing that, a lot of you would guess this one right here, the top part of the box is the upper quartile. It looks like in my excitement to label these things, I forgot to write in my 10 and my 85. Easy to do. Good to check your work. And then the 10 was the smallest number, but in math we'll call that the minimum. And we'll have over here the maximum, the 85. So they'll start to use these names here. And for the quartiles, I'm going to skip over range and actually define it because we're talking about them right now. But the quartiles are the 3 median numbers, or the 3 median values that divide the data. But like we looked on the last page, each of these sections is 25%. So you have 25% scrunched in here, 25% there, 25% stretches out over this big part, another scrunched 25%. So it not only divides the data, but it divides the data into 4 groups of 25%, or 4 equal parts. So I'm dividing those numbers into 4 equal-sized groups, even though on the chart they don't look equal, because it shows you the spread. The last thing I want to do is section 1. We looked at the range, and we said that the range was the highest number, the maximum, minus the minimum. So it's kind of looking at the total spread of the data. So range equals maximum minus the minimum. Got a little crazy with my M there. And so for this example here, you could really easily do it from your Box and Whiskers, just the 85, the maximum, minus the 10. So we have a spread of 75 right there. And we managed to fill everything in. So if you check out the I can statements at the end, that tells you what I'm expecting you to be able to do from this section. And let me know if you have questions if you're one of my students. Thanks.